everyone. In this session we are going to study errors. So let us first see the definition of errors. The numerical difference between the measured value and the true value is known as error. In analysis, during performing practicals, we often find that the result which we are obtained differ from the actual value. So this happens due to errors. Errors may be classified as determinate errors, indeterminate errors and cross errors. We will see one by one. Determinate errors, they are also known as systematic errors. They are further classified as operational and personal errors, instrumental and reagent errors, and method errors. We will now see one by one all the types of errors. Operational errors. So as the name suggests, it occurs during various operations. For example, during weighing or during drying of the sample. These errors are mostly physical in nature and occur when sound analytical techniques are not followed. For example, incomplete drying of sample before drying, or loss of sample due to effervescence or bumping. Personal errors. This may arise from the inability of an individual to make certain observations accurately, like inability to judge color changes sharply in titration, inaccurate burette readings, etc. So personal errors, they vary from person to person. For example, if the burette reading is 11.2, so if it is not observed properly, the reading may be recorded as 11.3 or 11.1 instead of 11.2. Next are instrumental and reagent errors. So as the name suggests, instrumental errors occur due to faulty construction of balances or due to uncalibrated or improperly calibrated balances, weights, glasswares like burettes, pipettes, etc. or attack of reagent upon glasswares and use of impure reagents. Method error. These are most serious as they are very difficult to detect. Non-ideal chemical or physical behavior of the reagent and reaction on which an analysis is based introduces systematic method errors. Example, slowness of some reactions, occurrence of side reaction that interfere with measurement process. Now often there might occur side reactions along with the actual reaction. Now the side reaction may lead to development of the product which may interfere with the measurement process. Indeterminate errors. They are also known as random error. They are known as indeterminate error because they cannot be determined. They are due to causes over which analyst has no control and are incapable of being analyzed. These errors may occur in spite of taking maximum care and patience. For example, in the standardization of an acid with a base, there may be slight variations in the procedure for draining the burette, in removing the last portion of the drop from the tip, and in deciding the exact color of the indicator at the end point. Cross error. They usually occur occasionally and they occur due to human error. For example, loss of part of precipitate before weighing. So how these errors can be reduced? So first method is calibration of apparatus and application of corrections. Calibration of apparatus means to verify whether if the apparatus is labeled to be of 10 ml then it actually delivers 10 ml or not. So each and every apparatus like pipette, burette, conical flask, beakers, they must be calibrated before use. That is, it must be verified that whether it is actually delivering the same volume or not. If it is found that apparatus is labeled to be 10 ml, but it does not deliver 10 ml. Instead, it delivers 9.9 ml. Then this 0.1 ml correction must be applied. Second method is running a blank determination. It consists of carrying out a separate determination omitting the sample. So here what we do is we carry out two determinations. In one determination we add our sample, and in the other determination we do not add our sample. So this will help in determining if the error is introduced due to reagents or not. So running a blank determination, it consists of carrying out a separate determination omitting the sample under exactly same experimental conditions as employed in actual analysis of a sample. So we have to keep all the conditions same as that of sample, but here only we do not add our sample. As temperature is kept same, reagents are also added similarly. So here object is to find out the effect of impurities introduced through reagents or vessels. Next method is running a control determination. Here what we do, we carry out determination of the standard substance under the same experimental conditions. So along with our test sample, we also carry out analysis of a standard substance. Then the result of the two can be compared, and it helps us in identifying the error. Result found for standard is divided by result for unknown is equal to weight of constituent in standard divided by weight of unknown. So by this way, if we know result for standard, result for unknown, and weight of constituent in standard, we can find out the weight of unknown. So by running a control determination, what happens? The error gets cancelled. Next is use of independent method of analysis. So here we carry out the analysis of the same sample by two different methods, and the result of both the methods can be compared. If we find that the result by the two methods do not match, it means that there is some problem in our analysis and the result we have obtained is incorrect. So accuracy of a result may be established by carrying out analysis in an entirely different manner. Example, in water hardness, calcium and magnesium concentrations can be determined by atomic absorption, may be compared with results obtained from EDTA titration method. So in water hardness, what we do, we measure the concentration of calcium and magnesium. Now this concentration can be determined by two independent methods. First is atomic absorption and second is titrimetric analysis. So if the result obtained by the two methods are close, it is probable that the values are correct within the small limits of error. But if the results obtained by two methods differ widely, it means that there is some problem in our analytical method. Next is standard addition. Here a known amount of constituent is added to a sample, which is then analyzed for the total amount of constituent present. So here the sample is spiked with the standard in different concentrations. And the difference between the analytical result for the sample with and without added constituent gives the recovery of the amount of added constituent. So here we can determine that whether the method gives same recovery as we have added the constituent or not. Next is amplification method. If the substance to be determined is in very small quantity, there are often chances of errors. So here what can we do? The sample can be reacted in such a way that every molecule produces 2 or more molecules of some other measurable material. So if the response obtained is in good amount, there are less chances of error. And from this amplified response we can calculate the actual sample. So this was about the errors, types of errors and the methods to minimize errors. Thank you.